This video is probably only good for about 100 people in the world. The people that decide to build a double or triple conversion radio from scratch, and they want to use a frequency counter along with it. So you come in with your frequency from the antenna. You come in, you come to a tuned bunch of coils, to an amplifier, then to your mixer. Now the frequencies coming in hit the mixer. Depending on what frequency the mixer has, the main oscillator. It sits on a dual conversion or triple conversion. Usually the first mixer has a fixed oscillator on it. So the band gets in, it becomes an inverse. And you go, what do you mean not inverted? Inverse. So the low frequencies coming into the mixer get converted to a high frequency. The high frequency ones coming into the mixer become a low frequency. So if you were to have it on a dial, you would mark the dial backwards. In this case, as you turn from frequency to band to band, you'll notice some of these are backwards. Some go from low to high, and some go from high to low. Now, I can't show you the color. For some reason, this camera doesn't want to pick up, but this bottom band on the kilohertz is black, and the top is red, and these up here, bands, some are red and some are black, depending on how many mixers are in the mix. I like that. How many mixers are in the mix. So if you build the circuit and you use just 2 mixers and you hook a frequency counter on, it'll be good for just one frequency. And then when you go looking for the other one, or the other ones, they're not going to be there in the right place, because they become an inverse, not inverted, inverse. So all your low frequencies coming into the first mixer become high. The amount, the amount of the product of the mixer. In other words, if you have a 10 megahertz crystal, all the low frequencies will be 3 minus 10 megahertz or 3 plus 10 megahertz. So there's a couple different ways you can do it, but I'm warning you about what's called the inverse. And I kept telling you, I was copying this radio, the Collins line, and I was telling you all they have to do is make the dial, calibrate the dial backwards. So if you want 45 megahertz, you would turn to that band and turn to 5. And whether you turn to the right or to the left, you wouldn't really pay attention to that. You're going for 5 megahertz. But then when you want 5.25, you're looking at it and you're like, I got to go backwards for that. And you're like, why do I have to go backwards? But that's the way it works for, say, that band. Now, in this case, you go to the band and you adjust your frequency. As you're adjusting your frequency up here, this would be the megahertz, and this is your kilohertz. So when you're on a band that's red, you use a separate dial here, because it's an inverse, and you have to understand that. So if you start creating a dual conversion radio, and you use let's say even amount of mixers, and your frequency counter from eBay will not work. If you just use one mixer, depending on the one mixer, you'd have a local oscillator, and then you'd hook your frequency counter to that local oscillator. So and then set your offset. So as you turn your dial, you're actually turning the local oscillator, and then everything converts correctly in the frequency counter, and you're happy. Everybody's happy. It's a single conversion radio. Now with a dual conversion, you come into an oscillator or into a mixer oscillator that's fixed. It's got a fixed oscillator with a crystal. So now the frequency coming in it becomes an inverse, and you can't put your frequency counter anywhere. It's useless. Now, it is possible to, if you know software, to go in and put an inverse in the program so the frequency counter will work correctly. But I'm warning you, you have to understand inverse. On this radio, it's very simple. The band, some of the bands have 2 mixers and some have 3. And they put the band that's messed up in red, and then you have to use a separate dial. And you're going backwards. So like I said, 5 megahertz, 5.25, normally it'd be 5, and you go to the right, 5.25, to go up in frequency, right? Remember that? Well, in this radio, the band you're on might make you go backwards the other way. And the kilohertz dial will be backwards. Now you switch to another band, and that band's correct because it's using 3 mixers. Now the AM broadcast band on this is right to left, left to right. Yeah, left to right. 0.5 megahertz is on the left-hand side, and 1500 is on the right-hand side. And that's because it's using 3 mixers. Now you go to the next band down, which would have, because the AM broadcast goes to 1500. So you want a frequency that's, say, sweet 16. So you switch the band, and now you got to go to the left to go up in frequency instead of going to the right. And once you understand this, you'll understand that why your frequency counter won't work with your homemade dual conversion radio. Now, a single conversion radio, you just grab your oscillator that's variable, it's your local oscillator, and you put that into your frequency counter. You know, you're going to need some resistors and caps, get the right voltage, and you go in your offset in the software, and you can set it through the buttons. And now when you move the dial up and down, it tells you the frequency. But when you go to a dual conversion radio, like a Collins, it's not going to work right. Now, I do believe there is a frequency counter for this radio, and it's very expensive. So I'm assuming that the person figured out that when you change the band on the frequency counter, it's going to do an inverse. And I just want to put that out there because that drove me crazy. I was putting signals through my mixers, and I was finding them with my R390, my DX390. But then when I went and put my frequency counter on my second mixer, because that's where the variable oscillator is, it was all backwards. You know, the oscillator was moving the frequency counter up and down, but the frequency that it was coming out of the mixer was an inverse. I hope you understand this. It's a little bit more, you know, when you go deeper into radios and you start designing things from scratch, you're not just copying somebody else's article. You start to say, you know what? I'm going to take an NE602 and I'm going to put a crystal into it, and I'm going to put my frequency into it, and I'm going to see what I get out, and it's an inverse. And I was like, what am I doing wrong? So I took the NE602 and ran a second NE602. It ran into a second NE602, which then did it did an inverse, so the output was coming out for the frequency counter correctly. Now you could do that. You could put that second NE602 in there just for the frequency counter. There's so many things you can do once you understand what the hell is happening. And that's where I always come in. I sit there and figure out why. And other people would just change parts. And sometimes that does work, but you never learn why. And then the next repair, you're afraid of the thing again. Anytime you shotgun, that's what we used to call a shotgun. In other words, you shoot at it and you use a shotgun and the pellets spread out and they hit everything. And with any luck, you get the thing working, and then you send it out. Then the next time it comes in, you're afraid of it, you shotgun it again, and then what's real fun is when the field starts saying they have certain problems, you don't understand how that piece of equipment actually works, and you're being paid to know how. And they're asking you and you're trying to duplicate what they have going on in the field. And then finally, when you understand, you ask a couple questions, and you find out that they don't know what they're doing out in the field. And then you can zero in on it and help them with their problem. But I just want to explain to you, when you look at this Collins, if you go read the manual, you'll see that they mention that there's certain bands that are in red. And then when you adjust your frequency for megahertz on this top band, and you could also, you can get pretty accurate with that, but then the real accuracy is this dial here, within so many hertz. And you'll notice some of the numbers, the upper scale is red and the bottom scale is black. So if you're on a red scale band, you use the red scale on here. I think that's it. All right, that's it.